G'day Year 7s and welcome to our next video tutorial. As you can see here, exercise 10E, looking at equations with fractions, which we have already done a little bit on in the first intro there in exercise 10D. So let's rip into this really quickly. So equations with a fraction. Solving equations that involve fractions is straightforward once we recall that in algebra, whenever you see a fraction like this, okay, the a over b, it actually means divide. So anytime you see anything, so even when you've got 1/2, 1 over 2, that still means it's 1 divided by 2. So this line here just means it is, whoops, again, one day I'm going to get this writing right, just means division. Okay, so that line just means division. This means that if we have a fraction with b on the denominator, forget the multiply on both sides, that we can multiply that b to the other side, as I've already told you and shown you in exercise 10D. Okay. Yeah, alright, so let's go to our next one. Now some of this you'll have to be careful what we look at here. So as we said, recall that a over b just means that's a division, so top divided by the bottom. So to solve an equation that has a fraction on one side, you don't multiply both sides by the denominator, you just multiply, forget that one too, you multiply that 5 to the other side. Okay, so in this particular question, if you multiply that, and we've done these questions, x equals, because the 5 has moved from this side, the left side of the equal sign, to the right side, so it's dividing here, so it's going to be multiplying on the other side, so x equals 20. Alright, now this is where the order is important. So we get a problem like this, you need to be very careful on what the order is. Alright, so remember, if we start with x, what's the first thing that has happened to x to get this problem? Hopefully you're sitting there going, well, firstly we've divided by the 3. Okay, so that's the first thing that's happened, is divided by 3, and then once they've done that, they've added the 5. Okay, so that's the second thing, is adding by 5. Alright, which means that we start at the bottom and we work our way up to do the opposite. So we're going to minus 5 first, and then we're going to multiply by 3. Okay, so forget this stuff on this side. There's a reason why it's there, but I haven't taught it that way. Yeah, so in this case, yes, we're going to minus start that again. Don't do this. Don't multiply by the 3 first. Okay, as we've shown here, it's divided by 3 first. So anything that's directly linked to that x, alright, so you know, if it was a 3x, for example, if it was written like that, first thing that has happened is that number. If it is an x over 3 in this case, that's still the first thing that's happened. So you've got to make sure you understand the order that has happened to x to create the problem that you see in front of you. Alright, so you don't multiply by 3 first, as we've shown here. We minus the 5 first. So we minus the 5 to both, sorry, not to both sides, we minus the 5 from this side to this side, because it's adding, so it's subtracting over here. So 8 minus 5 gives you the 3, and you're left on the left hand side here, x, I'm talking very fast, I know, I'm trying to slow down a bit. X over 3 is left because the 5 is now gone, and the 8 minus 5 is 3, and then we multiply because the 3 is dividing, as it says here, dividing, we now multiply it. So the 3 is multiplied, as you can see here, and 3 times 3 is 9, and all that we've got left here on the left side is x, so x equals 9. Now, it can be very different depending on how it's written, and so the expression x over 3 plus 2 and x plus 2 over 3 are different. Forget the flowcharts. So they're different how? How do you think they are different? Well, if you look at them here, in this particular problem, just the x is being divided by 3. Alright, that's the only thing, not the plus 2. So just whatever value you had for x, the first thing you ought to do to that is divide by the 3, and then you add the 2. But in this case, x plus 2, the whole lot, as is shown by the line, is under the whole lot, is being divided by 3. So in this case, whatever x is, we have to add 2 first, then when we get the result, we divide by 3. So just say x was 2 in this case, you've got to add, x is 7, for example, then you've got to add 2 first, which will give you 9, and then you divide that 9 by 3. Alright, but in this case, you'd have to divide by the 3 first. But in this one, you divide it by it last. A few more examples here. So you can see each of these are written a little bit differently. Okay, so in this case, all of 2x plus 3 is divided by 5. Alright, so the first thing that's happened to x is that you multiplied it by 2. Okay, that's the first thing. Then you've added the 3. And then all of that has been divided by 5. Okay, so if you're solving a problem like that, you've got to move the 5 first, then the 3, and then the 2 is the order that you're going. So you're multiplying the 5, subtracting the 3, I'll write these in, subtracting the 3 and dividing by the 2. Okay, this one a little bit different. You've got 2x, exactly the same numbers, but because the division part is in a different location, it's very different. Okay, so here only the 2x is being divided by 5. So in this case, the 2x plus 3, all of that is being divided by 5. But in this one, only the 2x is being divided by 5, not the 3. Okay, so if we're working out what has happened to x in this case, the first thing that happened to x is that we multiplied it by 2, because that's sitting right next to it. Then the second thing is that is divided by 5. And then the last thing is that the 3 was added on. So once we've, whatever x is, we multiply that x by 2, whatever the value is, to say it's 10. So we multiply 10 by 2, then we divide by the 5, and then the last thing we do to whatever that result is, whoops, not add 5, because I'm talking about 5, we add the 3. Alright, so when we're going backwards, we start here and work up. So we'd have to minus the 3 first. See how this is different? So in this problem, the way this one's written, we'd multiply the 5 first, then subtract the 3. But in here, because the division part's in a slightly different position, we're subtracting the 3 first. Then you multiply by the 5, and then you divide by the 2. Okay, so you've got to be very careful and look at the problem carefully and really understand the order of things that have happened to x to create that problem. Here's another one, a little bit different. You don't think you've got anything in this sort of complicated, but again, because of the brackets here, what's the only thing being divided by 5 here? Say it out loud, let it rip. Hopefully you said the x. Alright, so the first thing that happened to x here is that it was divided by 5. Then what happened? Well, looking at it, well, once whatever x is, once it's divided by 5, we're going to multiply it by 2. That's the next step. And then the last step is that 3 is added to it. Alright, so in our order here, we're going to subtract the 3 first, same as this one. But in this case, we're going to divide by the 2. That's our second step, working from bottom up. And then the last one is that we multiply by 5. So now these two guys have been swapped around, because the division is in a different spot again. Okay, so hopefully out of them you understand the difference between them, and it's really important that you understand what order the movement happens in each of these problems. Okay, because if you have a problem like this, for example, and you try and subtract the 3 first, you're going to get it wrong. If you've got a problem like this and you try and move the 5 first, you're going to get it wrong. If you've got a problem like this and you try and divide by the 2 first, you're going to get it wrong. Okay, so make sure the order is spot on. You've got to get the order right. If you don't get the order right, you're going to get the problem wrong. Okay, let's do a couple of examples. So solve each of the following equations. So here we've got a over 7, so a divided by 7 equals 3. So the only thing that's happened to a there is being divided by 7. So we're going to take this 7 from the left side of the equals, put it to the right side. It's dividing this side. We do the opposite. So now it's going to multiply on that side. So I'm left with a equals 3 times, remember if we're going from left to right, whatever's after the equal sign stays there. 3 times 7 is 21. Okay, again I can substitute that value back in if I wanted to, which I'm seeing some of you do that in your problems, and that's fine. It's good to do because you're checking your own work. You don't have to do it, but it's probably a reasonable habit to get into. So instead of a, I'm going to write 21 because that's what I've got the value for a there, divided by 7. 21 divided by 7 equals 3. So I know I've got that problem correct. Here, 5y divided by 5y divided by 3 equals 10. So the first thing that happens to y there is being multiplied by 5. The second thing is that it was divided by 3. So I've got to start at the bottom, work my way up. So I've got to multiply 3 first, then I'm going to divide by 5. So multiply the 3 first, taking the 3 from the left side to the right side. So all I'm left with now is the 5y on my left, 10 times 3 on the right. Again, modelling my working out when you guys do these problems. So now I've got that problem, so I've got to work out my 10 times 3, which is 30. Now I've done that part, now I'm going to divide the 5. So the 5 times y here, so I'm moving the 5 from that side to that side. Now don't model this working out where I'm drawing the circles and the arrows, you don't need to do that. So y equals 30 divided by 5, so y equals 6. Again, let's substitute that back in. So instead of 5 times y, I'm now going to write 5 times 6 divided by 3, which equals the 30 divided by 3. It's a really poor 3, which equals 10. All right, 10. So again, I know I've got that problem correct. All right, last one, or last two examples. A little bit more involved here. So let's go through. So what's the first thing that has happened to x in this scenario, in this problem? Well, first thing is that we've multiplied by the 3. Second thing that's happened, well, because of the division here, all of 3x is divided by 4, so that's the next thing that happened. And then the last thing is that 7 was added. Okay, so plus 7. So now we're going to work opposite. We're going to subtract 7 first, then multiply by 4, and then we're going to divide by 3. Okay, so let's do this. First thing is subtract the 7. So this guy, moving across there, adding, so now it's going to subtract on the other side, and all I'm left with here is 3x over 4 equals 13 take 7. So 3x over 4 equals, not writing very well, equals 6. Now, so I've done the minus 7, now I'm going to times by 4, so I'm left with 3x because the 4 is now on this side. So all I'm left with is the 3x on this side, so it's 6 times 4. I'm going to run out of room here. 3x equals 6 times 4 is 24. Done that part. Now I'm going to divide by 3. So because this is 3 times x, it's going to divide to this side. So x equals 24 divided by 3. So x equals 8. Okay. Now I'm not going to substitute that back in because I want to get through the this without having it too long. But if you substitute that in, you should get 13. Once you substitute that 8 for the x and work that out, you should get 13. Alright, last problem. Alright, so look at this very carefully. What's the first thing that happened to x in this case? Well, because everything up here is being divided by 5, multiplied by 2 is the first thing. Second thing, whatever x is, multiplied by 2, then we subtract the 3, and then everything, all of that, whatever happens up there, gets divided by the 5. Okay, so let's work opposite. Bottom up, multiplied by 5 is our first step, then we're going to add 3 in our second step, and then we're going to divide by, 2. Let's do that again, that's very poor effort at 2. Going to divide by 2 in our last step. Okay, so let's do this. So 5 is going to move first, the 5 up to here, so once we move the 5 is gone from this side to this side, we're left with 2x minus 3 equals 3 times 5. Thank you for the times. 2x minus, now I'm only looking here, now I'm finished with this problem, don't need to look at it because I'm working here now. So 2x minus 3 equals 15. Next thing I'm going to do is add the 3. So the 3 is now going to be gone over here, so I'm left with 2x equals 15 plus 3. So I've moved the 3 to this from the left side to the right side. It's minusing on that side, so it's got a plus on this side. So 2x equals 18. So we've done that one, now we're doing the divide by 2. So the 2 is now going to be gone. So x equals 18 divided by 2. So x equals 9. Cool bananas. They are. Don't doubt me, I was going to throw it in right at the end there. Alright, so hopefully that does make sense. Look, these aren't hard. Yes, there is a bit of a process to go through. But the important thing, again, the important thing out of this is that you understand the order that it happens. Because if you don't get the order right, you don't reverse it the right way, you're not going to get the right answer. Okay, so hopefully that makes sense. That is exercise 10E done for you. So hopefully you are well on your way. Again, we've got to work through this slowly. It's really important you get this stuff. So if you've got any problems or questions, please ask. The more problems you do with this type of stuff, the better off you are. So if you can find any other worksheets on the internet, any other sort of interactive type sites or hot maths in particular, get on that and practice those level questions in particular. Really important. Anyway, all over. Cool bananas. See you next time. Bye bye.